All right, section 2.2, adding rational numbers. Things to remember that your rules for adding fractions and decimals, they are not changing. Fractions must have the same denominator, and you need to make sure that when you're adding up and subtracting decimals that you need to line up the correct decimal places. So also you need to remember your basic rules for adding integers. A negative plus a negative equals a negative. A positive plus a positive equals a positive. But then when you have negative plus negative or positive plus negative, you need to subtract the numbers and keep the sign of the highest absolute value. So those rules that you learn in chapter 1 are not going away when adding integers, okay? So those same rules apply. And the same rules that are applying with adding fractions and decimals that you've learned throughout the years, they're not going away either. Those are the same things. So let's just go ahead and hit a couple of problems. All right, so this very first problem, we have negative 4/5 plus 3/20. So right off the bat, you need to understand that I cannot add these two fractions like they are because the denominators are different. So my job is to get them to have the same denominator. So this should be a little bit of review. What you're trying to find is what we call the LCD, okay? The least common denominator. Okay, that's what we're trying to find. So when we look at the denominators here, I have a 5 and I have a 20. So I need to find a number that both 5 and 20 can go into at the same time, or my LCD. Well, this one's a really easy one. My least common denominator for this is going to be 20. So what I'm going to do is I'm going to put negative, and I'm going to put 20 plus 320 here. Okay, so what I'm going to do is I'm going to change this 5 and I'm going to change it to a new denominator of 20. Now ask yourself, how did I do that? Well, what do I need to multiply 5 by to get 20? Well, I need to multiply it by the number 4. And if I do that on my denominator, I also have to do the same thing with my numerator. So 4 times 4 gives me 16. So negative 16/20 is also the equivalent of negative 4/5. These two are the same fraction. It's just that this one is not simplified. I've reversed it. Now that I have both of these with the same LCD, I can actually add it. Well, what do I do? Well, since I know they both have 20 as my denominator, I can say negative 16 plus 3 in my numerator. Well, and I have that all over 20. Now, knowing this is just a simple additions. All right, now, when we know we're not going to do anything with the denominator, so I'm just going to cover it up for just a minute. What's negative 16 plus 3? Well, since I have two opposite, one's negative and one's positive, I know I'm going to subtract. Well, that's going to give me 13. 16 minus 3 is 13 over 20. The issue, though, is this a positive 13 or a negative? Well, when we look at it, this number, 16, negative 16, has the greatest absolute value. So my answer to this would be a negative 13/20. All right? Let's do number 2 together. I have negative 8 plus a negative 6/7. Well, right off the bat, we know that this is an integer. This right here is not a fraction, but how can we turn it into a fraction? Well, we can turn any number into a fraction by just simply writing it over 1. So negative 8 is negative 8 over 1. Now my job is to find the least common denominator, which in this case is pretty easy, again, because notice that the denominator here is 7, so I'm going to do the same thing here. So I'm going to have a negative 7 plus a negative 6 over 7, all right? Now the issue is, what did I multiply this one by to get 7? Well, that's easy, 7. So I'm going to do that there. So 8 times 7 is going to give me 56. So now that I have this, I can put everything over the common denominator, which is 7, and I can say negative 56 plus a negative 6. Well, negative 56 plus negative 6 is going to give me negative 62 over 7. Now, it says write the fractions in simplest form. So this is the correct answer, but there is a better way of doing it. We need to ask ourselves, how many times can 7 go into 62? We can do a little bit of math on the side. But if you do it, and you can find out that, hey, it will go in there, 8 times. Okay? So we have an 8. And what's the remainder? It's going to be 6/7. Okay? So if you don't know how I went from here to here, and you got questions, please talk to me. All right, so I'm going to leave, no, I will do 3 for you. All right, the best thing when you are adding fractions, and you've heard this before, is to change everything from a mixed number into an improper fraction. It will save you a little bit of hassle. So we're going to do that now. I need to change this into an improper fraction. Well, to do that, I take the denominator and multiply it by this integer. 15 times 1 gives me 15, plus 2 gives me 17 over 15. I'm going to draw a little line here so I'm not getting too confused. So I have changed this into this. Now I'm going to do the same thing here. 2 times 3 gives me 6, plus 1 gives me 7. So this would be plus -7/2. All right, so now I have to find my LCD. Well, there's a couple of ways that we can do that, but the easiest way is probably just to multiply. And I know this from doing this multiple times, and you should do, but let's just pretend this how it is. I'm going to write this and count by 15s over the side. So I'm going to go 15, 30, 45, 60. All right, I'm going to stop there. And now I'm going to count by 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. And notice that the first number that they both have in common is 30. All right, so let's use that number. So I know that my least common denominator is 30 for both of them. All right, so what did I multiply this 15 by to get 30? Well, I multiplied it by 2. So 17 times 2 will give me, do a little math on the top here. That's going to be 2 times 7 is 14. Carry the 1, 2 times that gives me 2 plus 1 is 3. So that would give me 34 over 30. Now I'm going to, what did I do to get this 2 to become a 30? I multiplied it by 15. So I need to do a little bit more scrap work again and say 15 times 7. That's going to give me 35. Carry the 3, 7 times that, so I get 105. Whew, what a big number. But it's not just 105, it needs to be a negative because I did a -7 times 15. All right. Now that I've done that, it's just a matter of simplifying this out. So I know, well, I'm running out of room here, sorry about that. I know that I'm going to take 34 and I'm going to add a -105. And that's all going to be over 30. All right? So what does that give me? Well, I've got to do some scrap work. I know from looking at this, this has a higher absolute value. So my answer is going to be something, a negative something over 30. Now it's just a matter of subtracting. So again, got to do some scrap work over on the side. 105 minus 34. Well, this right here would be 1, and this right here would be 7. So it would be 71, -71 over 30. Well, this is the correct answer, but we need to simplify it. Ask yourself, how many times can 30 go into 71? It can go in there 2 times. What's the remainder? 11. So my final answer is -2 and 11/30. All right? Now, these are pretty intense just without a calculator, and that's what I want you to try. But before I give you these to try on your own, I do want to go over one more with you, and I'm going to leave the rest of them to you. But let's go ahead and look at number 7. So first off, let's look at it. I have 0.46 plus a -0.642. Right from the get-go, I need to ask myself, is this going to give me a negative answer or a positive answer? Well, when I look at these two, the highest absolute value happens to be this guy. So I know my final answer is going to be negative. All right, that's my final answer, it's going to be negative. And I also know that I need, since these two are, one's positive, one's negative, I simply subtract. So I'm going to line up my decimals, 0.642, and I'm going to subtract 0.46, okay? Well, technically there's a 0 at the end, so I'll put it there. So 2 minus 0, well, that right there, 0 minus 2 is going to give me So when I subtract, I'm going to do this. I'm going to go, can 0 be taken away from 2? Yes, it can, and basically it's 2. Can 6 be taken away from this 4? No, it can't, so I have to borrow. So this would be 5. This would become a 14. 14 minus 6 equals 8. 5 minus 4 gives me 1. And then I would have 0. Now, since I've subtracted it, I need to also remember that this was my highest absolute value, so my final answer is actually negative 0.182. All right? So what I want you to do is I want you to actually try the rest of these on your own, 4, 5, 6, 8, and 9, and see how you did. What you should have got for number 4 was negative 7/12. For number 5, negative 2 1/10. For number 6, negative 10 7/12. For number 8, negative 5.57. For number 9, negative 6.05. For this one, it says, before a race, you start 4 5/8 feet behind your friend. At the halfway point, you are 3 2/3 feet ahead of your friend. What is the change in distance between you and your friend from the beginning of the race? So I'm not going to work this one out because I want you to try it on your own, but I am going to give you a little bit of hint. So it says that at the beginning of the race, your friend was, and this would be you, at the beginning of a race, you were behind them by 4 5/8. Okay? And then at the halfway point, as you traveled, you got ahead of them by 3 2/3 of a foot. Okay? So you got ahead of them. The question is, what is the change in distance between from here to where you were behind to where you're now in front? So I'm going to let you kind of figure that out, but I wanted to give that to you as a hint. And I will see you in the next video. You know how to ask questions, so please do that, and see you next time. Bye-bye.